What if your network diagnostic tool could also teach you how to fix it? We have all been there. You are trying to connect to a service and it fails. You open your terminal and start firing off ping, dig, and curl commands. You get a wall of output that tells you almost nothing. That is exactly why the creator built NetworkDoctor. It is a cross-platform network troubleshooting tool that turns interface, DNS, TCP, TLS, HTTP, proxy, and path. Me2 checks into one plain English diagnosis. Instead of just handing you raw data, it answers the useful question: is the problem on my network, along the path, or at the service? It uses independent probes to distinguish between local link, DNS, egress, target, TLS, HTTP, proxy, and path Me2 failures. It even tells you what to do next with targeted fix hints and familiar drill-down tools that are just one key press away. Best of all, it needs no root access. Even the path Me2 check and LAN map use unprivileged sockets and bounded probes. It runs everywhere on Linux, macOS, and Windows. But the feature that got a little out of hand is challenge mode. It drops you into a simulated broken network and gives you the symptoms. It asks you to diagnose what is actually wrong. The same diagnostic engine that NetworkDoctor normally uses is available to you. The idea is to see whether you can interpret the evidence correctly. The scenarios include things like DNS failures, blocked ports, routing problems, connection refusals, dual stack, IPv4 and IPv6 issues, and other network faults. You make your diagnosis, submit it, and the simulator knows the actual fault so it can score the answer. I originally built the simulator for testing NetworkDoctor itself. At some point, I realized it was basically generating networking troubleshooting puzzles. So I made them playable. The simulator, netdoc-sim, builds a throwaway virtual network from a scenario and breaks it on purpose. It runs the real netdoc binary inside it and reports whether the diagnosis matched the injected fault. It is development and regression testing infrastructure that happens to be fun. The simulator has to distinguish DNS, routing, transport, proxy, TLS, and service failures. Testing that against the real internet is hopeless because you cannot break the internet on demand. A simulation makes the fault known by construction. That means netdoc machine readable diagnosis can be graded instead of eyeballed. No model, no heuristic, and no language model decides whether it was right. The comparison is between a structured expectation and a structured report. It is not a guess. It is a fact. There is a specific detail about how this runs on different operating systems that people often misunderstand. On Linux, every package installs netdoc, sim beside netdoc from the same release and at the same version. Nothing else to fetch. On macOS and Windows, the binary is not in the download. The backend is Linux namespaces, and there is no other one. macOS and Windows do not get a port and do not get an emulation. They run the same Linux binary inside a Linux container on the Linux kernel their container runtime already provides. The README notes that the host runs a container runtime which runs the simulator. It is the exact same Linux namespace simulator running inside a Linux container, not a macOS or Windows imitation of it. Playing your first one is incredibly simple. On macOS, Windows, or Linux, one container image is the whole install. No clone, no Go toolchain, no namespace knowledge, and nothing on your real network is touched. On Linux, any package installs netdoc, sim, and it runs natively with a single command. A single command runs the entire session because a simulated network only exists while the process holding its namespaces does. You get a briefing that names the machine you are standing on and the host you were asked about. You land inside the broken machine, use ping, dig, curl, IP route, SS, traceroute, and C, and whatever you would reach for on a real callout type exit in the shell to reach the menu. Pick your diagnosis by number, or type it by name. Then you get the reveal of the ground truth and the evidence. The post is currently sitting at 0 comments and 0 upvotes. However, the creator is actively asking for ideas for network failures that would make particularly nasty troubleshooting challenges. This is a great place for the home lab community to jump in. If you have ever dealt with a particularly confusing routing loop or a subtle MTU black hole, now is the time to share it. The goal is to make the scenarios harder and more realistic. Since the simulator is scriptable, complex multi-node failures are possible. This is a very open invitation for anyone who enjoys network deep dives to contribute to the scenario design. This is a perfect example of a tool that starts as a practical utility and evolves into a learning platform. NetworkDoctor is written in Go and uses the Biblitia TUI framework. It runs entirely in the terminal. It is practical because it fixes real problems. It is fun because it gamifies the troubleshooting process. If you want to sharpen your network diagnostic skills without messing up your production environment, this is the way to do it. The GitHub repository has the source code and the documentation is hosted on GitHub pages. It is a solid addition to any developer or sysadmin toolkit. I have linked the GitHub repository and the documentation for the simulator and challenge mode in the description. I want to hear from you. What is the most difficult network issue you have ever had to diagnose? Have you tried challenge mode yet? Let me know in the comments. If you enjoyed this deep dive into a practical open source tool, hit that like button and subscribe to ForgeStacx for more dev tools and self-hosted software worth your weekend. I have linked the GitHub repository and the documentation for the simulator and challenge mode in the description. I want to hear from you. What is the most difficult network issue you have ever had to diagnose? Have you tried challenge mode yet? Let me know in the comments. If you enjoyed this deep dive into a practical open source tool, hit that like button and subscribe to ForgeStacx for more dev tools and self-hosted software worth your weekend.